Okay, this is our final problem, number 10 on the 2.6 to 2.9 review. This is a free response problem, so I'll be talking about the point allocation for the work that you need to show. So even though a calculator is allowed for this problem, we want to make sure that we provide the work that is required in order to earn the points. So the first thing is part A. And I'm just going to do part A because B and C work very similarly, and I think hopefully with the answer key that's already printed that will suffice. So I'm just going to explain problem A. Part 1 of part A, we want to use the definition of the derivative of a function f at a number a to find the slope when x equals a. So one of the points on this section is going to come from writing f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So that's 1 point of your 9 already just for writing down the definition of the derivative. The second point is going to come from figuring out whether or not you can plug this a plus h into the function. So the next line would be f prime of a equals, and remember not to drop your limit because we have not computed it yet, and in here we will put 3 times a plus h squared plus 2 times a plus h minus 1. Notice up here in f, instead of writing x, we have written an a plus h. That means on this side, anything that is an x will be replaced with an a plus h, as you can see we've done here. Now we want to subtract the function when we plug a into it. So again, we come up here and replace the x's with a's. So that would be a 3a squared and a 2a minus a 1. Now what I have written right here has an error in it, and if you make this same error on the test, it's going to screw up your answer. Up here we need to subtract all of f of a, so to make sure that we keep that subtraction, once we've plugged a in, we need to put parentheses around f of a. So that's our second step, and that again is 1 point. The final point comes from crunching through all of the algebra to get to the correct answer. So we would still write our limit as h approaches 0, only this time we're going to multiply all of this out. So that'll give me a 3a squared plus a 6ah plus a 3h squared plus a 2a plus a 2h minus a 1. Distribute the negative, we get a negative 3a squared minus a 2a plus a 1. And again, this is all over h. Now if we've done this properly, then everything that doesn't have an h in it will disappear on the top. So that means the 3a squareds, the 2a's, the 1's, and everything that's left, the 6ah, the 3h squared, and the 2h have h's remaining. That means I can factor out the h's from the top, and I'm left with a 6a plus a 3h plus a 2 all over h. Now h equaling 0 will no longer be a problem because I can reduce out those h's and plug h equals 0 in. I'll get a 6a plus a 2. So there's the third point that goes with this first part. The second part says we want to use the slope that we just found to write the equation of a tangent line when x is negative 2. So in order to write the equation of a tangent line, we need a point and we need a slope. The point comes from taking the x coordinate and then plugging it into the function. So we'd have 3 times 4 is 12, minus 4 is 8, minus 1 gives us 7. We also need the slope, and what's fortunate is we have just found the slope in part A. F prime of A is 6a plus 2. So f prime of negative 2 will be 6 times negative 2 plus 2. That gives us a negative 12 plus 2 is a negative 10. Now that I have the point and I have the slope, I can write the equation of the line. Slope times x minus the x coordinate plus the y-coordinate. Notice I do not need to go any further than this. I'm done. So stop. You've got your points. And it looks like we gave 2 points for this. 1 point for getting the correct point and slope, and another point for translating that into an equation of a line. So now let's look at part 3. Part 3, the biggest mistake that people make when they're doing this part of the problem is that they neglect to use the different point. They try to use the same x-coordinate that they used in part 2 when they should be using this new x-coordinate of 4. So again, we want a normal line, which is going to require a point and a slope. Now remember, a normal line is one that is perpendicular to the tangent line. So this will be the opposite reciprocal of that f prime evaluated at 4. So let's find the y-coordinate that goes with 4. If I take 4 and I plug it into the curve, then I will end up with 55. And since you have a calculator available, I'm going to let you just plug that in and get a 55 out. To get the slope, remember f prime is this 6a plus 2. So if I plug a 4 in and then take its opposite reciprocal, I will get a 6 over a 24 plus 2, or a negative 1/26. Once I have the slope and I have the point, I can write the equation of the line, which is y equals the slope times x minus the x-coordinate plus the y-coordinate. Now, I'm going to point something out here because I see a lot of kids do this on the test. When they're writing the equation of the line, they neglect the y equals. They just want to give me this expression, and that is not an equation of a line. If you do that, you are not going to earn your points. So in this section, we again have 2 points. 1 point for finding the correct point and slope, and another point for putting it into the equation of the line properly. Okay, the last piece of this, part 4, says at what point is the tangent to the function going to be horizontal? So if we recall, horizontal lines have slopes of 0. So that means f prime of a, which we figured out in part A to be 6a plus 2, has to equal 0. If I solve for a, I will get a equals a negative 1/3. Now that will only provide me with the x-coordinate. So to get the y-coordinate, I will plug this negative 1/3 all the way up back into the original function. So a negative 1/3 squared times 3 plus 2 times a negative 1/3 minus 1 ends up giving me a negative 4/3. So in this particular case, you're going to get 2 points. 1 point comes from writing this equation down, showing me that you know the slope needs to equal 0. And the second point comes from giving me both coordinates of the point. That's it. Good luck.